Hello, ladies and gentlemen. I'm going to do my solution for section 2.4, question 10. The question reads, how many 5-digit numbers include the digits 4 or 6 or both? So think of some examples here. You could have a 5-digit number like 1, 2, 3, 4, 5, or 2, 3, 4, 5, 6, etc. As long as it includes a 4, or it includes a 6, or it could include both. So you could think of this as a good example where you could use the principle of inclusion and exclusion, because you could add all the ways that you could include the number 4, or all the ways you could include the number 6, and then subtract all the ways where you could have a 4 or a 6. The trouble is, it gets really complicated, because not only do you have to consider that there's a 4 in one of the 5 digits, but that there's, for example, 5 different places where you could put that 4. But if the 4 is in the first place, then you don't have to restrict the fact that there can't be a 0 in the first position. But if the 4 is in any of the other positions, you do have to restrict the first position and make sure that there can't be a 0 there. So you have to split it up into cases. And, I mean, if anybody is really interested in seeing how you could do this using the principle of inclusion and exclusion, or what I'll call the direct method, let's just say you're going to have to split it up into a whole bunch of cases. But I think you're better off doing this using the indirect method, which is to say that if event A is that there is a 5 or a 6, so it includes, 4 or 6, my mistake, includes a 4 or a 6, then that means that A prime doesn't include a 4 or a 6. And in order to use the indirect method, you're also going to have to consider the sample space. And the sample space is all the 5-digit numbers. So let's just remind ourselves of what the indirect method really will look like. We want to consider all the ways that event A can occur. So instead we're going to say that it's all the ways that you can generate a 5-digit number minus all the ways that you can generate something that we don't want, or the complement of A. So if we subtract the number of elements in the complement of A from the total number of 5-digit numbers, that should tell us the total number of ways that we can include either a 4 or a 6 or both. So here we go. Let's start with the easy part. The total number of 5-digit numbers with no regard for there being a 4 or a 6. Well, we have to consider that there are 9 non-zero digits, and out of the remaining 4 digits, they could be anything, and there's nothing about repetition or not, so there's 10 choices for each of those 4 digits, so 9 times 10 to the power of 4, I guess that would be 90,000 different 5-digit numbers. Okay, and I guess the smallest one would be, what would that be? 10,000, I guess. And the largest would be 99,999. 90,000 altogether. Then we want to consider all the ways that you could have a number that doesn't include a 4 or a 6. Well, there's 8 digits that aren't a 4 or a 6, and only 7 digits, one less than that, that's not a 0, 4, or a 6. And then there are, let's see now, there are 8 choices for each of the remaining digits, because we can't have a 4 or a 6, and there's 4 digits, so 8 to the power of 4. Right, does that make sense to everyone? So according to my calculator, that's about 28,672 ways that you can make a 5-digit number that doesn't include a 4 or a 6. So basically now we're going to say that the number of ways that does include a 4 or a 6 is the number of ways you can make a 5-digit number minus the number of 5-digit numbers we don't want, which is 90,000. Subtract 28,672, and that's about 61,328. Okay, hope that helps. This is one of those clear examples where using the indirect method is a whole lot easier and faster, I think, than trying to do this directly. If you tried to do it directly, chances are you didn't get to the right answer, and that's just because you probably didn't consider that the first digit can't be 0, and there's 5 different places where you could put the 4, or 5 different places where you could put the 6, or 5p2 different places where you could put the 4 or the 6. But that's not enough, because you also have to consider the fact that if the 4 and the 6 aren't in the first location, then you can't let there be a 0 there, and it just gets complicated. I hope that helps. If you really want to see the direct method solution for this, let me know, and I'll sit down and do it with you, but I think this is the way to go.